Okay, in this video we're going to be talking about more than one discontinuity in a function. So just a little bit of a recap. In the last video we talked about hyperbolic functions, which are the ones where you have some power of x dividing a constant. And essentially what we found was that this would usually approach two different values of infinity at a specific point where you were divided by 0. So in this case we have the function 1 over x minus 2, which means that if you approach the value 2, then that's going to approach infinity, but it really depends on which direction you're looking at. So if you're approaching it from the positive side, which is coming in from the right, then you're going to reach a value of plus infinity, whereas if you approach the value of x equals to 2 from the negative side or from the left hand side, you're actually going to approach the value of minus infinity. Because these two values are not equal, we essentially say that this is a function that is undefined at the point x equals 2, and therefore it is discontinuous at the point x equals 2. So that's a very important concept. Now, so far I've shown you how to analyze functions that we already know what they look like, but what about functions that we may not know what they look like in the first place? So can we use limits to plot a function like this? And this is probably the most important, I think the most important application of limits is you look at a function, you pick a bunch of values that you think are very important, and then you evaluate limits of the function at those points, and that allows you to actually plot the function without having to calculate a bunch of different values of x. So let's draw a set of axes. I'm going to draw my xy plane over here. Now the first thing we notice about this function is that if you plug in x equals to 1, then this quantity becomes 0, which means the whole denominator is 0, and you're going to reach infinity. So immediately you notice you're going to have a discontinuity. So we have an asymptote at x equals to 1, and the same thing is going to happen for x equals to 3, so you're going to have a discontinuity there. So that means we have two asymptotes in this case. So that's quite interesting because so far we have only looked at functions that have one asymptote or one discontinuity. So let's see what happens when we have two of them. Okay, the first thing I would do is I would want to see what the function looks like when you approach each of these points from different directions. So first of all, we can evaluate the limit of f of x as x approaches 3 from the positive side. Now, what does that actually mean? Well, if you plug in a value that is slightly larger than 3, like 3.01, then that means this is going to be positive, this is going to be positive, and then you're going to be dividing by a number that is very small because it's going to be very small. So you're essentially going to be reaching plus infinity like this. But as you go to infinity, then this whole thing will become 0. So that's essentially what you would get in that case. Now, so in this case, we would say this would approach infinity. If we take the limit of f of x as x approaches plus infinity, then that means we'll actually be reaching 0. Now the next thing is, okay, so what happens to the function when you're approaching 3 from the left hand side? So let's take the limit of this function as x approaches 3 from the negative side. What should we get? Well, now what we do is we pick a value of x that is less than 3, like 2.99. So if we pick a value like that, then all we need to do is just plug it into this function. So that becomes 1.99. This value over here becomes minus 0.01. And then that value is going to be close to minus 50.25. And what that means is that you're going to end up all the way down here. So as you keep making this closer and closer to 3, this value is going to get smaller, but it is still going to be negative, which means you're going to be going to minus infinity. So you're going to be coming off like that. However, that's not the whole story because we have another discontinuity over here. So we already have a sort of discontinuity at 3, but let's see what happens at 1. So in this case, we would say it approaches minus infinity. So let's look at it from the other side. Let's take the limit as x approaches 1 from the positive side, so of f of x. Now if we approach 1 from the positive side, that means 1 is x is greater than 1, so we can pick a value that is slightly greater than 1. But then this is going to be less than 3, so this is going to become negative. This is going to be very small, so this is going to become very large. But it is going to be a very large negative number. So it turns out that as we approach this value from this direction, we're going to end up with something like this. And it is going to go off like that. However, if we approach the value of the function as x approaches x from the negative side, which means in this direction, then what's going to happen is we're going to pick a value, sorry, that should be 1. Let me just erase that very quickly. That should be 1 from the negative side. What's going to happen is we're going to get a value for the function that is larger than 1, which means this is going to be positive, but this is still going to be, I guess, in some sense, it is going to be negative. However, if we look at it this way, this is going to be a value that is less than 1 because we're approaching it from this direction. So we could pick something like x equals 0.99, which would be on this side, somewhere over here. Then that means this value is going to be negative, this value is going to be negative, so both of them are going to be negative, which means this becomes a positive number that is very, very large because you're dividing by a number like 0.01 again. So this is actually going to come off like this. So it is going to go upwards to positive infinity once again. And the last thing we would do is just to check everything is consistent is what happens as x goes to minus infinity. Well, what happens is if this is infinity and this is infinity, we can pretty much neglect those numbers. They're not going to make much of a difference. So this is going to be minus infinity times minus infinity becomes plus infinity squared, which means it's going to become 0, but in the direction of minus infinity. So it's going to become like that. So it turns out that even though we had never seen this function before, we had no clue what it would look like. By using the concept of limits and evaluating the limits at just those 2 points, but looking at it from different directions, we managed to exactly just sketch the function and find out what the properties of that function are. Now, one very important thing happens when you're halfway between 1 and 3. So normally we would expect a function like this to be symmetric about the middle of the section. And it turns out that if you approach the value x equals to 2, so that's going to be 2 minus 1 is 1, 2 minus 3 is minus 1, so that becomes essentially minus 1. So at that point you're going to have minus 1 over here. If you approach it from the left hand side, then you're going to have the same situation. You're going to have something that becomes minus 1. So it turns out that this function is going to be symmetric about 2, which is expected because of the definition of the function. So that's a really interesting thing that I think is really important to know about, because once you know how to plot things like this, you pretty much understand how limits work.